Let's continue with our test review, starting here at question number 5. Here we're asked to find the derivative of this function, and when you look at that function, you need to ask yourself, is this a power, product, quotient, or chain derivative rule that's necessary? And we do see some fractions. It seems like maybe we might want to use the quotient rule, but actually if you look a little closer, this is a function. These fractions can just be rewritten as x's with negative exponents. And so we don't have to use the quotient rule at all. We can just do this using the power rule. Now, if you chose to use the quotient rule, it would require a little bit more work, but you would end up with the same answer. But I'm going to start out by rewriting 1 over x cubed. I'm going to change that to x to the negative 3 minus 1 over x is going to be rewritten as x to the negative 1 plus x squared. So that's our rewrite, and now we're ready to find the derivative. So we're going to take the derivative of this function just using the power rule. Negative 3x to the negative 4, because negative 3 minus 1 is negative 4. For my next term, this negative 1 is going to come in front. That's going to make that a plus 1x to the negative 2 plus x squared. The derivative there is 2x. And so that is our derivative. Now we're asked to evaluate this derivative at negative 1. And again, I think it's easier to do this if we go ahead and rewrite, get rid of these negative exponents. So I'm going to rewrite this function as negative 3 over x to the 4th plus 1 over x squared plus, and of course the 2x does not need rewriting. So now this is in a version where we can easily plug in negative 1 and get our answer. So at x equals negative 1, we get negative 3 over negative 1 to the 4th plus 1 over negative 1 squared plus 2 times negative 1. And so, of course, negative 1 to the 4th is just 1. So we get negative 3 here. Plus negative 1 squared is also 1. 1 over 1 is 1. And then 2 times negative 1 is negative 2. And if we add all of those together, we get our answer, negative 4. All right, question number 6. We look at this, we've got a function f, we're asked to find f prime, and so we should ask ourselves, is this a power, product, quotient, or chain? And as you look at it, it certainly seems to be requiring use of the chain rule. We've got an x squared function, a natural log, an exponential, so several functions embedded in each other here. However, the trick to this question is actually to notice that we could simplify our function a lot using log properties and the relationship between exponentials and logs. And so I'm going to simplify first before I take the derivative. I'm just rewriting the function down here. Now the first thing that we want to do, I'm seeing, first of all, I'm seeing this e with a natural log and the exponent. And I know that those two functions are inverse operations, inverse functions of each other, and that means they can undo each other. But I can't just cancel them out yet because of this 3 that's here in the front. It's kind of preventing the e and the natural log from undoing each other just yet. And so first up here, we want to use our log properties. We're going to take this number in front, and remember we can rewrite it over here as an exponent. So I can rewrite this function as e to the natural log of x squared cubed. Now that the e and the natural log are right there next to each other, there's nothing in between them, now they can undo each other, and this is actually just equal to x squared cubed. And whenever we have power to a power, we're going to multiply those exponents, and so this is equal to x to the 6th. And so what looked like a really complicated function in the beginning has now been simplified down to just be x to the 6th. Now this is, remember, this is still f of x. I haven't done any calculus yet. This has just all been simplifying. But we're ready to do a derivative now. F prime is going to be 6 times x to the 5th. and that gets us answer E. All right, let's move on to question 7. Here in 7, we have this function which is made up of u, v, and w, which are all differentiable functions. And our function is uv over w. So if we look at that and we ask ourselves, what derivative rules do I need? Is this power, product, quotient, or chain? I think initially it's really easy to recognize that we need to use the quotient rule. But if we look a little closer, here in the numerator we have u times v, and that indicates that we need to use the product rule as well. So I'm going to label this as f over g, and before I do the quotient rule, I'm going to go ahead and find f prime and g prime first. So f prime, the derivative of our numerator u times v, I need to use the product rule, which is f prime g plus g prime f, and in this case my f is u and my g function is v. Alright, just switch the color up there. So to find f prime, the derivative of my numerator, we're going to do the product rule, which is f prime g, and so for this function that would be u prime times v, plus the product rule goes on g prime times f, which for this product would be v prime times u. So that's my f prime. The g prime is, of course, g over here in our quotient is just w, and so g prime would be just w prime. So now I have f prime and g prime for my quotient rule, and I think we're ready to substitute everything in. For the quotient rule, I'm going to go ahead and write it out. F prime times g minus g prime times f. And let's just substitute everything in there. Sorry, that's not the whole rule. Over, and of course on the bottom we'll have g squared. So our f prime is u prime v plus v prime u. All of that is f prime, times g, which is w, minus g prime, which is w prime, times f, which is just u times v. And then over g squared, that of course would be w squared. And if I look up at my answer choices, I don't see anything that looks exactly like that. However, we can distribute this w into the function that we have there. And let me pause just. Okay, just erase that quotient rule to give myself a little more room to write the answer. So this would be u prime v times w plus v prime u times w minus w prime times u times v, all over w squared. And I don't have all those function letters in the same order for each term, but if you look closely enough, you'll see that answer matches answer E. Moving on to question number 8. Let f of x equal this function, 2x minus 1 to the 5th times x plus 1. Which of the following is the equation for the line tangent to the graph at x equals 1? So I look at my function. We're going to ask, what derivative rules do we need to use? Power, product, quotient, or chain? I see a chain rule here in this 2x minus 1 to the 5th. That's a chain. But then overall, we do have a product. These two functions are being multiplied together. So we're going to do overall product rule, but within that, a chain rule. So 2x minus 1 to the 5th times x plus 1. This, of course, would be f. X plus 1 is going to be g. So let's start out by finding our f prime. To find f prime, that's the part where we need to use the chain rule. And I see that my composite function has 2 layers. So I'm going to set up a chain rule chart. I have something to the 5th power, and that something is 2x minus 1. I'm going to do this derivative first. The derivative of something to the fifth would be 5 times something to the fourth, and the derivative of 2x minus 1 is 2. Of course, the 2x minus 1 is going to sub back in there, become the something, and so our derivative is 5 times 2x minus 1 to the fourth times 2. Or we could multiply that 5 and 2 together and just make this 10 times 2x minus 1 to the fourth. Alright, so that's f prime. G prime is just the derivative of x plus 1, which will be 1. So now we're ready to do our product rule. The product rule is f prime g plus g prime f. And so I'm going to substitute in for those things. My f prime is 10 times 2x minus 1 to the fourth times g, which is x plus 1, plus g prime, which is just 1, times f, which is 2x minus 1 to the fifth. So this is our derivative. Now my question is asking me for the equation of the tangent line. And so I'm going to pause and clean up a little bit here. Alright, so here's our derivative. Now remember, to write the equation for the tangent line, we need 3 pieces of information. We need to know what a is equal to, we need to know f of a, and we need to know f prime of a. We want the equation for the tangent line at x equals 1, so that is our a value. A is equal to 1. So I need to find f of a and f prime of a. For f of a, I'm going to substitute 1 back into f of x. And so f of 1 is equal to 2 times 1 minus 1 to the fifth times 1 plus 1. And this is equal to 1 times 2, which is 2. So our f of a value is 2. Now we need f prime of a, so that means f prime of 1. And so now I'm substituting 1 into our derivative function here, which would be 10 times 2 times 1 minus 1 to the fourth times 1 plus 1 plus 2 times 1 minus 1 to the fifth. And this is equal to 10 times 1 times 2 plus 1, which would be 21. And so 21 is my f prime of a. And now we have everything that we need to write the equation of the tangent line. I'm just going to remind us of the formula. Y is equal to f of a plus f prime of a times x minus a. And so y equals f of a, which is 2, plus f prime of a, which is 21, times x minus a, which is 1. Now the answer choices up there you can see are in a little bit more simplified version. So I'm going to distribute that 21 and then combine like terms with the 2 and the negative 21, and we end up with y is equal to 21x minus 19, which is answer B.